Today we're looking at triangle inequalities. There's kind of some fun things going on here. In the lower right hand corner is probably the most complicated thing, but it's a very complicated computer program which predicts protein structure and then tries to map it. It uses a Cartesian coordinate plane in a three-dimensional idea here. Pretty advanced stuff. It does use triangle inequalities in order to kind of do a guess and check method about your substrate of your protein structure. These are kids in a hallway trying to make triangles. Not sure why that came up. And then also here's some triangle with boots and ears. Basically the idea is that no two triangles are created equal, so that's why there's triangle inequality, I guess. Triangle inequality really means a lot more than this. We're going to use a triangle inequality to find possible side lengths in a triangle, and also to realize that the side lengths and the angles are related. So these are two really important concepts as we're working on this. Looking at this triangle here, this is obviously an obtuse triangle. I'm going to mark this as my longest side. I'm going to mark this as the shortest side, which in effect creates, this is my middle side. I'll just call it my middle side, middle in length. If I look at the angles, this becomes, let's see, this side is my largest angle. This is going to be my smallest angle. And this guy, I guess, is just going to be somewhere in the middle, my middle angle. So the idea here, if you look at this, the largest angle has the longest side across from it, which kind of makes sense to me. And the smallest angle has, let's see if I can trace this all the way over here, the shortest side across from it. And that's not really a coincidence. But the longest and the largest angle, the side that's open the most, is going to have the longest side kind of across from it. And the shortest, the one that has it's kind of closed the most, is going to have the shortest side with it. Now, these are summarized in two theorems. They're really complicated in words. It says if one side of a triangle is longer than the other, then the angle opposite the longer side is larger than the angle opposite the shorter side. And then it kind of repeats it kind of backwards, dealing with one angle of a triangle. So basically the angles and the sides are going to be related. These two pictures at the bottom really help to illustrate this. Your largest angle is across from your largest side like this. Your shortest side is going to be across from the smallest angle. Keeping this in mind, we're able to name the smallest and the largest angles. What gets kind of complicated is when you have an isosceles triangle. When you do have an isosceles triangle, we could probably name this either A or angle B. The ones across from the eights are going to be the shortest, and then I would say that angle C is going to be the longest. In number 2, if we look at, this is the shortest side, so the angle across from it is going to be the shortest, the smallest angle, I guess. 11 is the longest, so that means angle P is going to be the longest, or the largest angle. We'll do the same thing here. The smallest one will be angle H, and the largest angle will be across from 33, so that would be angle G. Over here we're doing exactly the opposite. Name the shortest and the longest sides of the triangle. So that's what we're looking at. The longest and the shortest sides. We're looking at those two pieces here. So as we work on this, number 4, we have to use the triangle sum inequality. Basically that the sum of the interior angles is 180 degrees. Figure out that this is 43 degrees. What we'll do is we'll just put these angles in order. This is probably what I would do mentally. And the one that's across from the 41 degrees, that would be RS, is going to be the smallest, or the shortest side. The one across from the 96, which is ST, is going to be the longest side. I'll do the same thing with number 5. Using the triangle sum theorem, I actually get that this is 58 degrees. So if I have 58 degrees, and 64 degrees, I'm just placing these in order from the smallest to greatest here. I definitely know that JH, which is across from the 64 degrees, is going to be the longest side. And then I'd say either one of the other two sides would be the shortest side. So you could say JK, or you could say, let's see, across from this 58 degrees would be KH. I'd say either one of these are the shortest. This is definitely going to be the longest. We'll do the same thing over here with number 6. Number 6, using the triangle sum theorem, we could find that this is going to be 82 degrees. So if we place these in order from least to greatest, this would be 17, 81, and 82. Those do sum together to give us 180 degrees. From there, what we do is we try to name the sides that are across from it. So this is definitely going to be AC, and the one across from 82 is definitely going to be BC. You can kind of guess a little bit just by looking at the picture, but it's kind of hard to tell at times. So it's good to kind of just put these in order. Make sure to use the triangle sum theorem to figure out the angles. If you're trying to construct or trying to form a triangle, it's kind of like forming a band. If you want a good band, you're going to have the right members in it. If you're going to have actually something that forms into a triangle, a viable triangle, you're going to have the correct length of sides. If you just go out there and all helter-skelter, just kind of pick out some random side lengths, if you have a 5 and a 2 and a 2, there's no way that you're going to be able to form a triangle. If you slide this thing down and this side down, these two ends right here and right here are never going to be able to meet. If you pick 5, 3, and 2, you'll notice that they will meet, but the only place they'll meet is right on the 5, and you're not really actually going to be able to form a triangle. They're just going to be lying right on top of this 5. So these two lengths, the 4 and the 2 in this case, they need to be just a little bit longer than whatever your longest side is. Notice that 4 plus 2 has to be just a little bit longer than whatever the 5 is. And that's what we're looking at when we talk about the triangle inequality theorem. Okay? Basically the idea is that if you add the sum of the lengths of any two sides of a triangle has to be greater than the length of whatever your third side is. So there's actually 3 of these. The one that makes the most sense to me is this middle one. Okay, I think the first one is pretty obvious. AC looks like it's probably maybe the longest side. Maybe AB is, I'm not really sure. But the idea is that you're going to pick any of these, and whatever your longest side is going to be, I'm not really sure which one it's going to be, but your largest or your longest side, I should write this, your longest side, it always has to be just a little bit less than whatever the sum of the other two sides are. So I'm not sure if that's really the middle one. I guess AC is probably the longest, so probably it's this first one that makes the most sense to me. So your longest side, we'll say, is AC, has to be just a little bit less than the sum of these two other sides. Let's see how this works in real life. They're actually giving us the triangle inequality up here. They're telling us that AB is and AC are the two shorter sides, and that BC is the longest, and we're actually going to try to solve for kind of a range of values, I guess, for x. So we'll just use this inequality. We said AB plus AC has to be greater than BC, which is going to be our longest side. So we'll just substitute values in here. AB is going to be 3x plus 1. We'll add in here AC, which is 4x minus 2. And that has to be greater than BC, whatever it is. This is 5x plus 7. I'll simplify this to 7x minus 1 has to be greater than 5x plus 7. Remember, with inequalities, you kind of just treat it like an equal sign unless you're multiplying or dividing by a negative number. So we'll just subtract 5x from both sides. That gives us 2x. We'll add 1 to both sides. That'll give us 8. Divide both sides by 2. And x just has to be some number greater than 4. Any number greater than 4 will actually satisfy this and make this actually a triangle. Number 8 works really, really similarly. So if we were to work it out, you just get a fraction, which isn't a really big deal. We'll just substitute this in here. X plus 5 plus 2x minus 1 has to be greater than 10 minus x. Again, that's AB plus AC has to be greater than BC. The idea here, we'll combine terms, is to be 3x plus 4 has to be greater than, again, 10 minus x. I'll get all my x's to one side, so that'd be 4x. I'll move the 4 over by subtraction, and so that'd be 6. When I divide both sides by 4, I'd have 6/4, or probably a better way to write this is going to be 3/2, and a lot of you guys know that to be about 1.5. The next exercise, this is actually really pretty tough. I think this is tough. I kind of got stumped just a little bit for doing this, probably just because I wasn't thinking the way I should have been. But here's the idea. This stuff is going to limit what's going on. It basically tells us that the measure of angle L is going to be the biggest, K is going to be the middle, and J is going to be on the end. So one thing that I know, I can definitely say that X, this length, which is going to be in the middle, this middle length, this definitely has to be less than 21. Okay? Another inequality that I can set up is basically that if I take 21 minus 9, that has to be, X has to be greater than that. So x has to be greater than the difference of these two in order to form this into a triangle. So I'll take this, I'll just simplify this a little bit, and I have these two inequalities, and I want to combine them. So this gives me that 12 has, or x has to be somewhere between 12 and 21, which makes sense. If this was 12, it would just match up perfectly with this. And if it was 21, this would actually become, if it was greater than 21, it would become the longest side. If it was actually 21, then this inequality right here would not be true. So it needs to be less than 21, it needs to be more than 12, or else it's no longer a triangle. We'll do the same thing with number 10, so if the first one didn't make sense, hopefully this one's going to make a little bit more sense. One thing we know, again, JL is going to be the middle length, so everything's going to be based on 15. So one thing that we'll say is that 15 has to be less than 12 plus x, which is going to be the longest side. So it has to be shorter than the longest side. Another thing that we know is that 15 has to be greater than the longest side minus the shortest side. So that would be 12 plus x minus, this is 20 minus x. This is kind of a weird thing to write out. I'll work with this one first because this one's easier. So this would be 12 plus x, I'll just write this out, 12 plus x minus 20 plus x. We'll leave this inequality symbol in here. That'll give us 2x minus 8 has to be greater than 15 or less than 15. That'll give me 2x has to be less than 23, or that x is going to be less than, I'll just call this 11.5 for ease of use. I'll quickly solve this other one by subtracting 12 from both sides, so I know that x has to be greater than 3. What I want to do then is, just like I did in the last one, I want to combine these two. So just like I had one inequality and a second inequality, and I made a compound inequality in the end, I'm going to do the same thing here. So x has to be in the middle. You always want your inequalities pointing towards the left. You always want them pointing towards the left. So I'm just going to put my 3 here. This has the x in the middle. The x is pointing towards a 3. The same thing here. X is pointing towards a 3. In this case, the 11.5 is pointing towards the x. So that's why this works. So your x, just a range of values for your x's, has to be between 3 and 11.5. Kind of a tough problem. You might want to back this up and just check to make sure that you understand it. These problems I think are really useful. I really like doing these. These are really kind of fun. Very simple concept here. I'm going to start with 15 because I think it makes more sense than 14. We'll go back to that. Here's your pattern. Describe the possible length of the third side of a triangle given the lengths of the other two sides. So the idea is that I don't know what my longest side is. I don't know what my shortest side is. But I know one side's going to be 9, one side's 5, and one side's going to be x. So what I need to know is that x is going to be somewhere in between two values. Okay, x might be the longest side, x might be the shortest side. So that's kind of what I have to look at. All you do is you take your biggest number minus your smaller number, and you take your bigger number plus your smaller number. This will give us 4 is less than x is less than 13. X can be any number between 4 and 13, not including 4 or 13. If x was 4 here, this side would be too small. It would be just, these two sides would just add up to 9. If this side instead was 13, if I could really add this, it would really help. This is 14. Not to really try to confuse you, but 9 plus 5 is 14. So if this was 14, I don't even know what that is, then these two sides would just be able to barely make it across here. So the idea is that x just has to be some number between 4 and 14. And the rule for this, the simple rule, all you do is you subtract the two numbers and add the two numbers. These always have to be positive. Same concept over here. We'll say 6 minus 6 has to be less than x, has to be less than 6 plus 6. So that just means that x has to be some number between 0 and 12. Basically, this is going to be an isosceles triangle. This is going to be 6, this is going to be 6. This just has to be some number between 0 and 12. We're working with yards. We'll do the same thing. We'll say 11 minus 6 has to be less than x, has to be less than 11 plus 6. So this would be 5. This is 17. I really like this. This is so easy. I could do this all day. If I could get a job doing this, that'd be sweet. This is kind of weird. Notice that our units here are feet and inches. I'm just going to cross this out. I'm going to make this 2 feet. We could convert everything to inches. The important thing is that these two must be the same units. Then we'll just go through the same process. 7 minus 2 has to be less than x, has to be less than 7 plus 2. So the idea here is that 5 has to be less than x, has to be less than 9. These are in feet. We can convert these to inches just saying that 60 is less than x is less than 108 if we're talking about inches. This one's feet, this one's inches. That's why units are usually an important thing when you talk about mathematics. Last problem we're going to look at, basically the shortcut. This is mathematically proving the idea that shortcuts are actually shorter than the longer distance. Okay, so kind of the shortest distance between 2 points is a straight line as opposed to going through this. So it says you are walking your dog. I would really like to hear that you have a dog. I have a dog too. Maybe they can go for walks together someday. That'd be really nice. You're walking your dog north on the sidewalk of Peach Street. Okay, when you reach the 14th Street, you cut across the park. You daring fool, you. You cut across the park just like this. Just the corner of 13th and Sassafras Street. Explain why taking this route is shorter than continuing to walk to 13th Street and then to Sassafras. So it's saying, why is that path shorter than you continuing up Peach Street and then cutting over this way? Well, basically we have a triangle, okay? So is it shorter to go this whole length plus this whole length, or just cut across basically your hypotenuse? Well, what we need to do is we need to basically look at the triangle inequality. So I would say something like this: according to the triangle inequality theorem, which we just learned a little while ago, triangle inequality theorem, the sum of the length, this is really bad handwriting, of the two sidewalks, that's how you spell sidewalks, basically Peach and what's the other one, 13th Street, so basically the green here, is greater than the length of the third side. Here, this is really bad handwriting, third side, which is basically cutting across the park. Okay, so here's where we have, I kind of wanted to model this for you just a little bit, that you can actually write like a sentence. It just needs to make sense. According to what theorem? The triangle inequality theorem. And basically we're going to say the sum, so adding these two guys up, is going to be greater than the third side, which is this. In other words, duh. Okay? What I want you guys to do is I want you to try some of this stuff on your own. You're given 3 lengths here. They're not really nice lengths, but you need to basically determine whether it's possible to build a triangle out of these. If so, or the measure of the angles. So maybe you have to draw a triangle in order to figure this out. Order them from least to greatest. Not the sides, but the angle measures. Okay? Then it says describe the possible values for x. These are similar to the problems that I thought were fairly challenging. You may have to use some inequalities, and it might be kind of difficult for you, but I want you to give it a try. I hope that you guys realize that while you're doing math, you're either part of the solution or you're part of the problem. So make sure you're on the good guys' side. I guys, hope you have a great time. Math is life.